Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture, today I am going to discuss about the problem solving question on AO* algorithm. Already I have discussed few problems related to the local search, the knowledge representation also. This is the next video. So after the completion of the course, students can apply the bounded look-ahead strategies to predict future steps for decision making in given applications. Okay, before going to discuss about this AO* algorithm, let me tell you why this AO* algorithm is required. Actually, AO* algorithm is a type of informed search algorithm which is used for problem reduction. Especially, even it is also used in the game playing also. What is the meaning of then problem reduction? If the problem is too complex, then it will be very difficult to solve using a simple search tree. So in that case, we can go for AO* algorithm, which can give, it not only give a single solution, it can give multiple solutions. So out of multiple solutions, we can recognize which one is the optimal one. Especially in the problem reduction technique, what happens if the problem is too big or too complex, then that problem can be divided into number of sub-problems, and each sub-problem will be solved separately, and the solution of each sub-problem gets combined to find out the final solution of the main problem. That is what it is. That is why it is called as the problem reduction. So under this problem reduction, this AO* algorithm is one of the important algorithm. So let me discuss what is the algorithm, then we'll go for to solve. We'll solve one or two problems. So AO* algorithm, the name of the algorithm is called as AO*, which is an advanced version of A* algorithm. So here AO* means and or. A stands for and, A stands for and O stands for or. That is why the name of the algorithm is called as AO* search algorithm. So it requires few steps for this algorithm. The step 1 says that initialize the graph to start the node. After that, step 2 says traverse the graph following the current path, accumulating the nodes that have not yet been expanded or solved. Step 3, pick any of these nodes and expand it, and if it has no successor, call this value as futility. Otherwise, calculate only f dash. F dash here, it is the meaning of f dash is the heuristic value of the node for each of the successor. Then step 4 says that if the f dash, that means the heuristic value is 0, then mark the node as solved. Step 5, change the value of f dash for newly created node to reflect its successor by back propagation. I will explain you all these steps with the help of example. Now step 6 says, whenever possible, use the most promising rules, and if a node is marked as solved, then mark the parent node as solved. If starting node is solved or value greater than the futility, then stop the process, else repeat from the step 2. Okay, let us come to the problem here. This is the first question. Find the optimal solution using AO* algorithm. As I discussed, this AO* algorithm, it is called as and or. Like for example, in my real life example, to own a mobile phone, either you steal from somebody, that is one way, or else you work hard and you own a mobile phone, you purchase a mobile phone. So there are two ways are there. Either you steal from somebody, it is the easiest way, or else you work hard and you can purchase it. So whenever I am saying you can steal it, that means it can be represented with the help of a single line. That is called as the OR node. And another option I have given that you work hard. Suppose this is you work hard and you purchase a mobile phone. That means both the options needs to be satisfied to purchase a mobile phone. So that is why one ARC is given. That means to achieve this result or to achieve this goal, both the options needs to be satisfied. Then only I can purchase a mobile phone. Just I am giving this example, real life example, but here in this case some numbers are given in this tree. I will explain how this Evo-star algorithm can be applied to find out the optimal solution. Now what this tree says that this tree is having S is the root node here. Root means this is the goal node. To achieve S, the main goal of this Evo-star algorithm is how to achieve S. That is the root node. So there are two ways are there. One is S to C, this path is there, or else ASB, this path is there because one arc is given. So either you follow this path, means the right side part completely C, F, G, or else you follow this path by starting with this one ASB, then you follow accordingly. So any one option you can follow, but we have to find out which one is the better solution. As Evo-star provides more than one solution, from that more than one possible solution we can find out the optimal one. And one more thing here, in Evo-star algorithm, one important thing is here in this tree, the values which are given with red colors, these are the nodes like S, A, B, C, D, E, F, G and H. These are the nodes. S is the goal node here. This is the goal node. We have to find out, we have to achieve S, and for every edge the value is given as 1. That is nothing but the actual distance from the goal node to the current node. That means the goal node is S. To suppose my current node is A. What is the actual distance? That is 1. Same thing from A to D, the actual distance is 1. So like this, the actual distance is given from the root node to the current node. So that is denoted as Gn. And all the red color values, and here the actual value Gn is considered as 1. For every edges, it is considered as 1. Whereas in other cases, like if you consider the A-star algorithm, that may the Gn value, it may vary. Whereas in Evo-star algorithm, the Gn value is constant. Even if it is not given in our problem also, you need to consider that it is 1. Okay, so what is the meaning of, now one of the formula is there in Evo-star algorithm. So that formula is the cost function, which is denoted as Fn, that is equal to G of n plus H of n. Then what is G F of n? So if you want to find out the cost of A or cost of any node, that can be calculated using G of n. G of n is the actual distance from the root node to the current node. Now from the root node S to the current node A, the actual distance is 1. So I can write 1 plus H of n. What is the H? H stands for heuristic value. Heuristic value means from the current node to the goal node. Okay, from the current node to the goal node is called as the heuristic value. So heuristic value of 7, for A it is given as 7. So that we can write 1 plus 7, that becomes 8. Okay, so like this we can use this Fn function that is equal to Gn plus Hn. Now we will solve this example which is given in our screen. Now to find out the optimal solution for the goal node S, we can use this function everywhere. Fn is equal to Gn plus H of n, right? So path 1, we have two paths. As I told, one is S to C, another path is ASB. So first path we will calculate that F of S to C. How to write F of S to C? That is equal to G of C plus H of C. Why I'm not writing S to C for G of S to C or H of S to C? No need to write. Directly you can write the child node. So whenever we are calculating the actual distance G of any node or heuristic value of any node, you always prefer the child node. So from S to C means who is the child node? C is the child node. So that is why the formula would be F of ST is equal to S to C is equal to G of C plus H of C. Then what is the value of G of C? Means from the root node to the C distance, it is 1. And H of C, what is the value here? It is 13. So it becomes 14 now. Right? So this is one way. Another path we will calculate, path 2. What is path 2 here? F of ASB. This is another path. Either we'll follow this path or we'll follow this path. We'll decide first. So A is B. How to write because here the two children are there, A and B of S. So in that case, we can write G of A plus H of A plus G of B plus H of B. Now what is G of A? That is equal to 1. From H to A distance is 1. H of A is given as 7 plus G of B it is given as 1. H of B is given as 12. The heuristic value of B is given as 12. Then what is the total value here? 7 plus 1 is 8 plus 1 is 9. 12 plus 9 it would be 21. Right? So for path 1 we got 12 and for path 2 we got 21. So if you compare between this minimum between 14 and 21, which one is minimum? So minimum value is 14. So here we can write the cost of S, we got that 14 now. For the time being it is 14. But still now we have not explored the complete search tree. We have to explore again because some subtrees are there from A onwards and here also some subtrees are there below C. So let us find out now. So cost of S we got that 14, which is nothing but the minimum between we got 14 and 21, that is equal to 14 we got right now. Okay. Now as it is 14 from which side we got F of SC. So let us explore F of SC path completely. So under SC means from C node again the path is there F and G, which are where there is one arc. That means both CF and CG should be satisfied to achieve C. Okay. So now what we can do? We can find out C of FCG, that is equal to what would be the formula? G of F plus H of F. Similarly plus G of G plus H of G. Now what is G of F? It is 1. It is given as 1. Plus H of F. What is the heuristic value of F here? It is 5 plus G of G, that is 1, and H of G, that is 7. Now what would be the value? 5 plus 1 is 6 plus 1 7. 7 plus 7 it becomes 14. But what is the heuristic value of C is given here? It is given as 13. As it is 14, the previous heuristic value will be discarded and new heuristic value will be added. Right? So as per the AO* algorithm, if the heuristic value of any node is changed, then that heuristic value will be propagated to the parent also. That means from C to S, again we have to find out the cost. So what would be the cost of FC? Once again we'll find with new heuristic value of C, then it would be G of C plus H of C. So what is G of C? It is 1. But H of C now it is 14. So 14 plus 1 it becomes 15 now. Now 15 means this cost of S now it has been changed to 15, not 14. I hope you might have understood. From this side completely we have explored and we got the cost of S we are getting as 15. Now we'll search the left side part. Okay, so what is the cost? Previous value, the cost of F of S, it was 14. Now the revised cost, the revised cost of S, it becomes now 15. Previously it was 14. Now we'll explore from this ASB already we have explored. Now we'll explore A. So how to find out the cost of A? Already the heuristic cost is given as 7. But from A, two child are there. One is AD and AE, and there is no arc. That means we have to find the cost of AD. Then we'll find out the cost of AE for the node A. Then we'll compare which one is minimum. Based on that, the heuristic value of A will be changed. Now let me find out F of AD. So F of AD, now I'm not writing the formula. So F of AD would be what we can write? G of D plus H of D. So what is G of D? It is 1. H of D, heuristic value of D is 5. So it becomes 6 now. Now F of AE. AE, what is the value? So what would be the formula? G of E plus H of E. G of E is 1 and H of E is 6 it is given. So 6 plus 1 it is 7. Now you find out the minimum between 6 and 7, it is 6. What is the heuristic value of A is given? 7. So it is replaced with 6 now. As the heuristic value of A has been changed and it should be propagated to the parent node as like before. So again we have to calculate f of A S B. The same formula we have to follow as I have done before. So G of A plus H of A. G of A is 1, H of A is 6. So 1 plus 6, and this side G of B is 1 plus H of B is 12. So what is the value here? 6 plus 1 is 7 plus 12 plus 1 is 13. So 13 plus 1 is 20, right? Now the value of S here, the value for the goal node value we got here 20, but previously what we got 15. So which one is minimum? Definitely we'll choose that 15 would be the feasible one. So one solution, this side we are solving, this complete right side we solved, we got the value 15, and complete left side still now I have not solved D and H. I will tell you why we have not solved D and H, because at this level we are getting the answer which are different from each other. If whenever we are solving the right side we are getting the value 15, and when I solve this left side part we got 20. That means between 15 and 20, definitely 15 is the minimum cost, right? Though we are getting two answers, but in AO star algorithm sometimes we have to discard. We should avoid if the node is present in beyond the depth. Means if like one depth is different from another depth, in that case, and if we get some right answer and we can compare the answers to different values, then no need to search even if any node is present beyond the depth. So we can ignore this part and this would be the final answer. So two solutions we have right now. One is 20, another one is 50, but the optimal solution is 15 now. So this is what the problem, this question, this is the way we can solve. One thing we need to remember. So Fn is equal to Gn plus Hn, this formula, and Gn value for all the edges, it is considered as 1. And whenever we are calculating for any heuristic value, then that should be propagated to the goal node. These three things we need to consider here. Now let us solve another question. Find out the optimal solution using AO star algorithm for the given search tree. Now similar pattern but little bit different here it is there. Like here the nodes are, the A is the goal node. The main goal of this particular problem is how to achieve A. Under A, 3 children are there. One is B, C and D. So how we can achieve A? Either we'll follow AD path, because this is a OR path, only one solution we can find, or else we can follow BAC, because one arc is there between B and C. That means both AB and AC should be satisfied to achieve A. So if I follow BC, the complete left side path we have to follow. This is my right side path to follow. So both the sides we have to solve, then we'll see which one is the optimal one. Okay, let me solve first. As I have already discussed, the cost of any node we can find out using this function. F of n is equal to G of n plus H of n. Gn is the actual cost and Hn is the heuristic cost. Now let us find out first for path 1. Okay, so what is the path 1 here? Path 1 is f of A to D. So f of A to D is equal to, now I think you might be thinking why the age values, the Gn value is not given in this search tree. Now if the Gn value is not given in any search tree, then you need to consider the Gn value for all the edges, it should be 1. That means this one is 1, this is 1, this is 1. All the edges are considered as 1 by default. You have to consider even if it is not given. Okay, for your safe side I have written over here, but in our example previously it was not given. Now f of AD is equal to what we can write? G of D. Who is the child here in A to D? D is the child. So G of D plus H of D. So what is G of D? G of D is equal to 1, and H of D, what is the heuristic value of D? It is 8. So 8 plus 1 is 9. So this is one path. Another path which is path 2. So f of B, A and C. F of B, A, C, how to find out? So G of B plus H of B and plus similarly G of C plus H of C. So G of B, that is equal to 1, and H of B, the heuristic value of B, it is given as 5. Similarly, h of C, g of C is 1 and h of C is 11. So you add all the values. 5 plus 1 is 6 plus 1 is 7 and 11 plus 7, that is equal to 18. So the heuristic value, so what are the two values we got for the node A? We got one is 9, another one is 18. So we'll find which one is minimum. Minimum between 9 and 18, it is 9. So now we can write the cost of A is equal to 9. For the time being, it is 9. Now we have to explore the complete tree. Only the level 1 we have explored. Then we'll go to level 2. Then we'll go to level 3 if it is needed. Otherwise, we'll stop once the difference number we find at a particular level. Then we have to stop the process. Okay. So what was the cost we got here? Let me write once again. Cost is equal to cost of A is equal to 9 now. That means the heuristic value of A is equal to 9. Out of 9 and 18, we got 9 is the least value. Now, as 9 is the least value, from which side we got? We got from AD, because when we calculated the this side, BAC side, we got the cost as 18. But right side path, when I explored, we got the cost as 9. So now the next step is we have to explore the right side completely. Means D, we have to find the cost of D node. So how to find? So f of D, actually here we cannot write f of D. Here from D, if D is the root node, then to achieve D, there are two children. Okay, so one is H, another one is I. Both the paths needs to be satisfied. That means H and D up to and H and I, both the path needs to be satisfied to find out the cost of D. So as this arc is there, so how I can write f of H D I, that is equal to G of H plus H of H plus G of I plus H of I. So G of H, that is equal to 1, because the actual cost from the root node always it is considered as 1, and because now as I am calculating from HDI, now the root node is D only. So from root node, what is the G in value? It is considered as 1. Heuristic value of H is given as 3. G of I means DI distance, it is 1. By default, it is 1. And H of I, it is given as 3. So 3 plus 3 is 6 plus 2. Now it becomes 8. What was the given value here? Previously also it is given as 8. No need to change anything. Now should I explore this or should I move this heuristic value to A? No need to move. Even if you move also, you will get the same value as 9. Right? Because the heuristic value does not change as it was before. No need to explore once again. Now come to the right side part. Still we are maintaining the cost from the complete right side path is 9. Now come to the left side part. Already BAC we have explored. Now we'll find out the cost of CG, means the cost of C. Okay, let us explore F of C and G. Okay, this is the left side path. A cost of C to G means that is equal to, we can write G of G plus H of G. What is G of G? That is 1 and H of G is 1. So that is equal to 2. But what was given here? 11. So let us discard this 11 and it becomes 2 now. The heuristic cost of C is equal to 2 now. Now we will explore this path. Okay, if we consider this is the root node B is having two child, one is BE and one is E, another one is F. So two paths BE and BF separately we'll calculate, then we'll compare their minimum heuristic value to change the cost of B. Now you can write directly, I can write F of BE. F of BE, that is equal to G of E plus H of E. G of E is 1, H of E, heuristic value of E is given as 4. So 1 plus 4, it becomes 5. Similarly, the cost of B to F, what is the value here? 1 plus 7, that becomes, 1 plus 7, it becomes 8. So now you find out which one is the minimum. Minimum between 5 and 8, that is equal to 5. What was the heuristic value before for B? It is given, it is 5. So no need to change. Okay, now should I explore to the root node? Yes, I have to explore, because as I am considering the complete left side part, the heuristic value of C has been already changed. Now you find out f of B A C. What is the value here? Because C value has been changed, B value remain constant. So if I write, so G of B, that is equal to G of B plus H of B plus G of C plus H of C. What is G of B? That is equal to 1. H of B is 5 plus G of C, it is 1. H of C is 2. What is the value here? 5 plus 1 is 6 plus 1 7 plus 2 9. So we are getting 9. So what we have observed, even the value of C has been changed, and we explored to the top to the root node, we are getting the same value as 9. So now the problem is here, up to certain depth, like this level is done, this level is done. Even if we explore this first level and second level, we are getting the same answer. Whenever we explored the right side part, we got the cost of A is as 9. When I explored the left side part, this up to the same level, we are getting 9. Now the problem is, if both are 9, I cannot find out the optimal solution. To overcome that problem, again I have to explore this EJ path also. Then EJ path I will explore, then I'll update the value of E, then I will update the value of B, then I'll update the value of A. So then we can find out which one is the optimal path. Let us do that. Okay, now explore E to J. F of E to J, because E is having one child, F of E to J is equal to G of J plus H of J. What is G of J? G of J, that is equal to 1, means the distance between E and J is 1. That is called as the actual cost from E to J, and heuristic value of J is considered as 1. So 1 plus 1 is 2. But what is the F of EJ means we are calculating the cost of E node. So previously the cost of E, it was given as 4. Now let us change to 2. As it has been changed, again I have to find out the cost of this BE. So F of BE, that is equal to G of E plus H of E. What is G of E? G of E is 1, H of E is 2. That is equal to 3. Similarly, F of B to F. B to F, that is equal to G of F plus H of F. So what is G of F? Plus 1, and H of F, it is equal to 7. 7 plus 1 is 8. So between these two, what is the minimum value? 3. Then what would be the B value before? B value before, it was 5. Now we have to change as 3. And it has been already changed. I hope I have told. It has been already changed as 2. Now you explore the path F of A, B, or you can write ABC, or any way you can write BAC. Any way you can write F of BAC or ABC, that is equal to, while calculating the formula, you have to consider the child node always. So G of B plus H of B plus G of C plus H of C. Now what is G of B is 1. H of B is equal to 3. Now it has been updated. G of C is 1 and H of C, it has been updated 2. So 3 plus 2 is 5 plus 2, it is 7. Now what we have observed, previously the cost of A right side path we got as 9, but now the new cost we are getting as 7 after exploring the complete left side tree. So two solutions to achieve the goal node A. One is the left side part, which is 7. Another one is the right side part. It is 7. It is 9. So optimal one we can say ABC path. If you follow ABC path, complete left side path, will get the optimal solution. So this is the way Eostar algorithm problem can be solved by using this left side and right side, means by solving both OR path as well as the AND path. So I hope you might have understood both the problems what I have explained using Eostar algorithm. So for the preparation of this video and the concept of Eostar algorithm, I have referred this Heuristic for Artificial Intelligence book. Even you can also refer it. For your reference, I have kept this picture on the screen, which is available in the Amazon website. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.